Hey everyone, this video is going to be talking about triangle medians and the centroid and what all that means. So real quick, in any triangle, doesn't matter the shape of the triangle, the size of the triangle, you can draw what's called a median. A median is a segment that connects one vertex to the midpoint of the opposite side. That is called a median. And it turns out if you draw all three of those medians, they will intersect at a very convenient location. And that location is called the centroid. Here's what it looks like visually. Look at that. I can drag those points anywhere I want, and you'll still have this point right in the middle. It's where those medians intersect. Notice that all of these segments along the side of the triangle are cut in half. They're bisected. But that point inside of it, they still meet, and that point is called the centroid. So let's fill out some formal definitions. The median is a segment connecting a vertex of the triangle to the midpoint of its opposite side. The point where those medians intersect is called the centroid. It's the point where all three medians are what we call concurrent. And that's a fancy word from math, just saying where they come together, where they meet. So that's going to be, in this case, point G. There are a few properties you should know. A very useful property in medians and centroids is that the segment connecting one vertex to the centroid is actually twice as long as the remaining part of that median. So if you look at those lengths here, that's about 1.7 centimeters. And this is going to be about just under 1 centimeter. So that's going to be about half of that. More formally, we would say that this segment right here is 2/3 of the entire median. So we would say AG is 2/3 of the whole thing, AD. CG, similarly, is going to be 2/3 of CF, and BG is going to be 2/3 of BE. But it also is going to form a 2-to-1 ratio with the smaller part of the median. So that's useful in solving problems. Let's go over a few examples. In example 1, triangle SAT, P is the centroid, PR is 4, PT is 10, AR is 8, AY is 12. We want to label those. So PR being 4, we're going to put a 4 right there. PT is 10. We'll label that as 10. AR is 8. That's going to be over here on the side. And AY is 12. We want to find all these different segment lengths. So I'm going to start with SP. The relationship between SP and the whole median is that this segment is going to be 2/3 of it. But the way I want to think about this problem is SP is just going to be twice as long as the shorter portion of that median. So all I'm going to do is take that length of PR right there, and I'm going to double it. I'm going to say 4 times 2. So SP is going to be PR multiplied by 2. It's going to be 4 times 2, and that's just going to be 8 units long. Now, if I look at the whole segment length, that whole segment length, SR, that would be 12. Similarly, if I go to TM here, I want to know the whole thing here. Now, what I do know is that PT is going to be 10. So what I can do from there is I can take that 10 and I can cut it in half. And I can say, well, that 10 divided by 2 is going to be PM. So first thing I'm going to do is take 10 divided by 2, and that's going to be 5. But then if I want to get the entire segment length TM, I'm going to have to add these two together. So I'm going to basically say 5 plus 10. And that's going to get me back up to 15. So, TM is the longer of the segment. This is 2/3 of it. 10 is 2/3 of 15. This is 1/3 of it. 5 is 1/3 of 15. And then this is twice as much as that. Going over to AT. Now AT over here is along the side. And medians do split the side in half. So I know that if that's 8, that's going to be 8 as well. So this is going to be 8 times 2, which is going to be 16. And then for PY is going to be this segment down here. And we blocked most of our writing up here, but if you do look up here, I do know that AY is 12. So I'm going to pause the video and redraw this. A lot of times on these problems, you end up covering a lot of your workup. So I'm just focusing on the important part for this problem. I know that AY is equal to 12. I was given that in the problem up here. So what I'm going to do is label that 12. I just want to know PY. Now, PY is actually 1/3 of the entire segment length. So to get PY, you would take that 12 and divide by 3, and that's going to give you 4. So if I wanted to know that this length, that would be 4 times 2 to give you 8. And this would be 4. 4 plus 8 is going to give you 12. That's the whole thing. But I just want to know PY there. So that's going to be 4. Let's look at number 2. Number 2 is a centroid example as well, but it involves a right triangle. So it's going to have a little different approach to this one. This one is going to probably involve Pythagorean theorem. Anytime you have a right angle, that's usually what's going to be involved, or trigonometry. So in this problem, I get right triangle ABC. And what I notice that is I have BA is 9, and I have the entire length of AC is 12. First thing I want to do on that problem is chunk that up, cut that in half. A centroid will divide the side by 2. So I'm going to call that 6 and 6. Now I want to find the length of BF. Now, in order to get that, I'm going to have to know the hypotenuse of that. So the first thing I did was I cut that side in half, since that is a centroid. The second thing is I want to know what is that whole segment there from B to, there's no letter here, so I'll just call that from B to, we'll call that the hypotenuse, lowercase c. Maybe I'll call it X to not confuse with the C down here. And if you pull out that right angle, you have a 9 squared and a 6 squared. Call that X. And you can use Pythagorean theorem. A squared plus B squared equals C squared. Substitute your 9 and 6. This is going to be your C, since X is your hypotenuse in this case. So we'll plug that in. We'll solve for X, and then we can answer the question. So 9 squared plus 6 squared, we'll throw that into our calculator. That's going to give you 117. And then we'll take the square root. And the square root of 117 is about 10.8 units. So how do I get BF from there? Well, BF is 2/3 of the entire segment length. So if I know this whole thing is 10.8, then what I'm going to do is I'm going to take that 10.8 and divide by 3, but then multiply by 2. So to get BF, I'm going to take this number, 10.8, divide by 3, and then times it by 2, since it's 2/3 of the entire length. 10.8 divided by 3, 3.6 times 2, about 7.2. So the answer to the question is 7.2. BF is approximately 7.2. And since our units were in centimeters, we'll write cm, centimeters. All right, thanks for watching. You can try your centroid problems and let me know if you have any questions.